Hello. Hello. Hello.
Good morning, sir.
Good morning. Okay. Uh, okay. So what we have started IR filter design. So until last class, what we have seen, that different poles in S plane that is to be mapped in jet plane. Then we are trying to find the procedure or techniques by which I can map S plane into jet plane.
Good morning, sir.
Morning. So last class, what we have discussed, where we stopped actually, we have discussed the stability criteria in time domain as well as in transform domain. In case of continuous time system, we have tried to investigate stability problem in time domain as well as in S domain. There we have seen that in order to have a stable system in S domain, what we have to have that poles have to lie in the left of S plane. That is we have seen. That is the S domain stability condition. Time domain stability condition, that is over the limit of impulse response, it has to be a finite value. These are the two things in time domain stability. Correspondingly, frequency or S domain stability. For digital systems, these things are time domain in digital domain, and correspondingly transform domain is the jet domain. Therefore, the system stability we have considered in both S and jet domain. Now we have said earlier that in IR filter design, what you have to do, first we have to convert the digital specifications of frequency into analog domain. Then we have to design an analog filter, means you have to find the HS transfer function. And once we design the analog filter, then I have to transform this S domain function into Z domain function, S domain function into a Z domain function. And once we transform S domain function to Z domain function, then it will be a digital filter. So for digital filter, IR digital filter, they are essentially designed with the analog filter. So digital frequency specification converted into analog frequency specification, and that analog frequency specification will design analog filter. Then we have to transform this analog filter into digital filter. Thereby, we will design IR digital filter. Then we will find frequency response and realization. So the first step is we'll discuss first and second step one by one. Now, an impulse response which is in analog domain, that will be in the form of 1 by S plus Pi. Then I have transformed this into this step we have discussed. If you have do you have any doubts in previous discussion? I hope you have no doubt. Then in that we have seen that a pole of S plus Pi that will be transformed into E pi 1 minus e to the power pi into t into z inverse. This is the transformed. I have explained how to get this. Therefore, a pole in S domain that will be transformed, or a transfer function 1 by s plus pi type will be transformed into 1 minus e to the power minus pi of t into z inverse. Then I said s plus pi equal to 0, s equal to minus pi. Then if you simplify, this is equal to 0. This is equal to 0. That means for digital pole, this is for analog pole. A pole means your denominator equal to 0, that gives you the pole. Numerator equal to 0, that gives you the 0. Now denominator equal to 0 means s by pi equal to 0, so s equal to minus pi, that gives you analog pole, and 1 minus e to the power minus pi t z inverse is equal to 0. If we find the value of z, this will give you the digital pole. Then I said that s equal to minus pi, then you write pi equal to s, therefore this will be equal to e to the power minus s times t. Previously I have written si, but for that will be create confusion, so therefore we will write si in next step. This step I am writing e to the power minus pi into t and pi equal to s minus pi equal to s, so I will write e to the power minus st. But however, you should remember this z is essentially zi and this is essentially si. So I can write z equal to power st in general, but I can remember that zi equal to power minus sit. What is the meaning of that? The meaning of that is each analog pole that will be transformed into a digital pole. Right, S1 is the first pole, second pole, like that. If we are having a number of poles in the analog domain, and correspondingly we will be having a transformation in the Z domain. So similar number of poles in S and Z domain. Okay. Now, at this stage, I hope you have understood this is how the relation between Z and E for S. This gives a relationship between Z and S, which says that S domain pole will be transformed into digital Z domain pole, Z equal to E power ST. So this is something we have to understand. So this is the relation between Z and S using impulse invariant transform. Impulse invariant transform is a technique by which we can find a mapping relationship between S plane and Z plane. In exam, there is a possibility of getting a short note of impulse invariant method as well. So these are the steps you have to derive. All right. Therefore, with this understanding that z equal to e power st, that using this relation we will convert S domain pole into a Z domain pole, then your S equal to, in general, Si equal to sigma I plus j omega I. This omega I am writing like this. This is called analog frequency, and this omega I will write small omega, that will call digital frequency. This is a distinction between analog and digital frequency that will be used for higher filter design. So therefore, whenever I will refer analog frequency, I will write capital omega, and when I will refer digital frequency, I will write small omega. Okay. Now, in general, I said Si equal to sigma I plus omega, j omega I. S equal to sigma plus j omega, which you already know in your Laplace transforms. Okay. In fact, S equal to sigma and j omega, your x-axis is your sigma and y-axis is your j omega. That you know already, I hope so. Once you know this, now sigma I equal Si equal to sigma I plus j omega. That means if I substitute S equal to Si equal to 1, then S1 equal to sigma I, sigma 1, j omega 1. Then I will write Z1 corresponds to e to the power sigma 1 plus j omega 1 into t using this relationship, Z equal to e power st, which I have derived as term. Therefore, what we will find that Z equal to e to the power sigma 1 t, magnitude of Z, and phase equal to omega 1 of t. Is it all right? Magnitude of Z equal to power sigma 1 t and angle of Z equal to omega 1 into t. Is it all right?
Yes, sir.
Very good. Therefore, what I can conclude that for poles lying left up S plane, poles, I am saying that poles lying left up S plane, the poles at left up S plane, what is the corresponding sigma 1? That will be less than 0.
Yes.
Yes. If sigma 1 is 0, then magnitude of Z1, if sigma 1 is negative, this will be equal to less than 1. Less than 1.
Yes.
The magnitude of Z1 will be less than 1. What I mean to say is that poles are lying in the S plane, that then these poles will be mapped into Z plane within the unit circle,
इसे आगे बढ़ बोलो ना.
See, when sigma 1 less than 0, which means the poles in the analog domain lying in the left upper plane. And when sigma 1 less than 0, what I found that magnitude of z less than 1, z equal to 1 corresponds to unit circle in the z plane. The magnitude of z less than 1 means this pole will be located inside the unit circle.
हाँ.
Yes. Therefore, what about others? Others under getting the point?
Yes, sir.
বাকিরা বুঝতে পারছো? অরিত্রিয়া, নুপুর, সঞ্জনা, সবাই বুঝতে পারছো?
Yes, sir.
Very good.
Yes, sir. Yes.
Okay. All right. So, what I have just now given the argument that the poles that are lying in the left of S plane that will be mapped into within the unit circle of the Z plane. Now, if you refer the previous class lecture when I said for analog system stability, the poles have to be in the left of S plane, and similarly for digital system stability, the poles have to be within unit circle. Poles have to be within unit circle. That I have discussed in the last class with two examples. When I have shown you that when poles are within the unit circle, then in digital system or Z domain, it will be a stable system. If the poles are lying outside the unit circle, then digital domain or S domain, it will be an unstable system. That we have discussed. Now, if we consider another case of poles are in the right of S plane, in such a case, sigma 1 greater than 0. Agreed? Sigma 1 greater than 0. When poles are lying in the right of S plane, then sigma 1 greater than 0. If sigma 1 greater than 0, then what will be the value of Z1? Z1 equal to e to the power sigma 1 into t. If the sigma 1 greater than 0, what will be the value of Z1? Value of Z1 greater than 1. If it is greater than 1, magnitude of Z1 is greater than 1. What does it mean? It means that poles are lying outside the unit circle. It means poles are lying outside the unit circle. If you remember the lecture I have given in the previous class, that digital system stability, I have taken two examples when poles are outside the unit circle. In this case, system is unstable. And poles within unit circle, system is stable. That I have discussed in last class. Now here what I have seen, that if you use the mapping Z equal to for ST, corresponds to this mapping, poles which are in the left of S plane that are mapped into within the unit circle, which is the left of S plane. Poles are right of S plane means they are mapped outside the unit circle. Therefore, if the system is stable in the analog domain, then system will remain stable in the Z domain. Is it all right?
Yes.
Very good. So this is one thing that because I have to convert S domain system into Z domain system, because I have to design analog filter, then I have to convert this analog filter into a digital filter transfer function. Therefore, I have to convert S function into a Z function. Therefore, which means for analog SI lie on the left of S plane, the corresponding digital pole Zi will be inside the unit circle in the Z plane. For analog pole SI lie on the right of S plane, corresponding digital pole Zi will be outside the unit circle in the Z plane. Now for sigma equal to 0, if I put sigma equal to 1 equal to 0, then Z equal to 1. Is not it? If it is 0, this will be equal to 1.
Yes.
Which means that the poles lie imaginary axis. If I say sigma equal to 0, means poles are in the imaginary axis. dash corresponds to digital pole. Zi will lie on the unit circle in the z plane. All the unit circle in the z plane. Okay, these are the three cases. There is nothing beyond this. Now, relation between analog frequency and digital frequency using impulse invariant method. Now, you know, omega, capital omega, I'm writing analog frequency, which is radian, analog frequency, radian per second, and digital frequency, radian per sample, second hour sample hour. Now, Z equal to R into e power j omega. You know this? Z equal to R into e power j omega. Achha. Now, S equal to sigma plus j omega. And Z equal to e power st. There are three relations you know. Z equal to R into e power j omega, you know from the Z transform. S equal to sigma plus j omega, you know from Laplace transform. Z equal to e power st that I have derived for Laplace invariant, impulse invariant method. Now, what I am doing, Z I am writing R equal to e power j omega, and S I am writing sigma plus j omega. So R into e power j omega, omega is your digital frequency, this omega is your analog frequency. Then R into e power j omega equal to e power sigma plus j omega t. Now, this omega is your digital frequency, this omega analog frequency. Then what I can write here, that this j times omega, this j times omega, this is the phase of this omega, and phase of this is omega t. So what is the relation between this? Capital omega equal to this is analog frequency, that will be digital frequency by t. T is your sampling time. So this is the relation between analog frequency and digital frequency. Agreed? Fine.
Yes.
Now, this is omega. So I'm writing 2 pi fa. Fa means analog frequency. 2 pi fd means digital frequency. And this is t. So what I can write, fd equal to fa into t. That I can write fa into fs. T, if the t is the sampling time, then fs is the sampling frequency.
Sampling frequency.
Therefore, digital frequency is the analog frequency divided by sampling frequency. This is the relationship between digital frequency and analog frequency. Okay. Therefore, as I have said earlier, the digital frequency specification we have to convert into analog frequency specification. I mean, digital frequency specification need to be converted into analog frequency specification. That could be done using this relationship. Using this relationship, I can convert digital frequency into analog frequency. And once I get analog frequency, I can design analog filter. Of course, we have to know what are the techniques to design analog filter. That I have to know. Once I design analog filter transfer function, analog filter transfer function, then Z equal to e power st. This is the transformation. And also we know that any analog transfer function that can be converted into a digital transfer function using this particular technique. Then using these techniques, I can convert an analog system or analog filter transfer function HS into a Z. All right. Now we'll discuss one example of, suppose HS is given, how could you find HZ? That I am discussing one example. This is not a filter design, but this is a example for analog transfer function HS. Determine HZ using impulse invariant transformation for t equal to 1 and t equal to 0.1 second. This is the question. Acha, any doubt if you have so far what I have to cover? Do you have any doubt? Anybody? Anybody having any doubt they can ask? No doubt? কারো কোনো doubt নেই যারা পড়ছো?
No, sir.
Everything all right? Very good. ভালো কথা. Now HS. HS কি দেওয়া আছে? This. তাহলে HS টাইম কিভাবে লিখতে পারবো? I can write HS equal to 2 by s plus 1 s plus 2. I can write a by s plus 1 b by s plus 2. Then a equal to HS. HS means this multiplied by s plus 1 is equal to minus 1. This is what is called partial fraction method, which you have discussed in detail in Z transform. So you might have understood this, that you have to multiply HS with s plus 1 and you have to calculate for s equal to minus 1. You will get A. Similarly, you can get B by HS. You have to multiply by s plus 2, then s equal to minus 2. From here also you can do that, because if you calculate A means s plus 1 into this quantity, that will give you A, and B means it will be multiplied with again same s plus 1. So this part will goes to 0, then this part will get minus 2. Agreed? Any doubt you can ask at this stage also? Any doubt? No doubt? Ananya? Doubt nahi to? Oh, very good.
No.
Similarly, you can find A and B. Once you find A and B, then you can write H is equal to 2 by S plus 1 plus minus 2 by S plus 2. Right? So you can substitute A and B and you can get. Now, using impulse invariant transformation, what I know that AI by S plus PI, that will be transformed into AI by 1 minus e to the power minus PI into T into Z inverse. That is we have derived. That is what is impulse invariant method. Now I have to apply this here. How do you apply this? See, this is your PI. PI টা কোথায়? E to the power minus PI. তার মানে 2 by S plus 1, তাহলে কি হবে? 1 minus e to the power minus 1, right? Minus 1. আর t টা কত? T equal to 1. If t equal to 1, then t equal to 1, so it is minus 1 into Z inverse. তাহলে এটার আমার ট্রান্সফরমেশন হয়ে গেল। এই টার্মটাতে কি হবে? P equal to 2, so I'll write 1 minus e power minus 2 Z inverse 2 by this. Later হয়ে গেল। Hz will be like this. Once I get Hz, then what I have to do? Then what is the value of E inverse? E equal to, I have written here, value of E I have written somewhere. This is the value of E, 2.7182818. Right? You need not remember this. You have calculator, right? You can always calculate in calculation. So if you substitute this value, this is 1 minus e to the power minus 1 Z inverse minus 2. So e to the power minus 1 I have substituted, e power minus 2 I have substituted, 1 minus this into Z inverse. Then if you simplify this, you will ultimately get this function. So if this is your S function, and this is the corresponding your Z function. Right? This is how we have converted a S function into a Z function. Any doubt?
স্যার
বলো।
স্যার এ আর বি এর ভ্যালুটা বেরোনোর পর ওই জায়গাটা একটু বল।
এটা এ আর বি ভ্যালু বেরোলো, এটা এ আর বি এর ভ্যালুটা বেরোলো তো। এ এর ভ্যালুটা বেরোলো 2, বি এর ভ্যালুটা বেরোলো -2। তাহলে এটা হচ্ছে a বাই s প্লাস 1, b বাই s প্লাস 2। তাহলে a এর ভ্যালুটা আমি 2 বসালাম আর b এর ভ্যালুটা -2 বসালাম। তাহলে কি দাঁড়ালো? তাহলে এটা কি দাঁড়ালো? 2 বাই s প্লাস 1 -2 বাই s প্লাস 2। এইবার এইটাকে আমাকে z এ কনভার্ট করতে হবে। তাহলে s প্লাস pi টা কি হবে? 1 বাই e টু দি পাওয়ার মাইনাস pi ইনটু t ইনটু z ইনভার্স। এটা আমরা প্রুফ করেছি, উই হ্যাভ প্রুভড দিস। তাহলে এইবার এখানে pi টা কত লিখবো? pi এর জায়গাটায় লিখবো আমি 1। তো pi টা আমার 1, এখানে pi মানে হচ্ছে 1। তাহলে pi এর জায়গায় 1 লিখলাম, t ইকুয়াল টু 1 আমাকে দেওয়া আছে, তাহলে আমি 1 ইনটু 1 মানে -1 টা হলো আর z ইনভার্স হলো। করসপন্ডিংলি এইখানে এটা 2 আছে, pi টার ভ্যালু 2 আছে, তাহলে e টু দি পাওয়ার মাইনাস pi মানে আমি -2 লিখলাম। ওকে, ইনটু z ইনভার্স। বুঝা গেল? তাহলে সিমিলারলি you can convert this, then after that if you simplify, then we will get this hz equal to 2 into this if you simplify this you will get this. Now interesting observation in that, like if you compare these two transfer functions, then here also you are having two poles locating at s equal to -1, s equal to -2. Now these two poles are in left up S plane. So this is essentially a stable system. Now therefore, if we look at this, if you simplify this further also, then if you look at that, if I multiply this, suppose say z square, and then what are the location of the pole? Location of the pole will be 0.36 and 0.13. They are all within the unit circle. There are poles that are there in the left up S plane that will be mapped within the unit circle. So this is something. Now assignment, you will take this one, you can solve this easily of your own, that t equal to 0.01, then you solve hz. That you do in your own. Now this is one technique, I mean different kind of poles could be transformed. Now this is I didn't derive. Suppose if you have multiple order, So if you have poles at pi of order m, then these are the formulation. Like the same thing we are having here, we have to find one derivative and minus 1 to the power. These things we will discuss when we will have a specific problem during filter design. And suppose if you have a filter transfer like this, s plus a by s plus a whole square into b square, this kind of thing I'm not deriving, but anyway we can derive this as well, not an issue. But we are directly lying. You can derive the way I did this problem, but this derivation is not required. Only thing we have to use this result. Then how to use this result, when I will discuss a problem regarding that during filter design, at that time we will discuss these things, how to use this formulation. This derivation I am not doing. We can do, you can do that if you want this formulation, what he did. Okay, so this we will discuss if whenever the problem comes, how to use this formula in the designing of filter. With this, my topic of impulse invariant method I complete. Next topic that we will discuss in this is another important technique. This is called bilinear transformation, that we will discuss in the next class. Next class I will take in when? Saturday. Okay, next class I will take in Saturday. Saturday I will discuss another technique of transforming S to Z, and this is known as bilinear transformation. All right. So if you have any doubt, you can ask, or otherwise I will close the today's lecture. If you have any specific doubt, then you can discuss. Apart from that, one more thing I want to tell you, that you should be starting revision of your previous course, what is already covered. All right. Since I have reduced the number of classes into 4 into 2, therefore revision time I may not get much revision time anyway. Your course will be learning till August. Do you know this?
না স্যার জানি।
তোমাদের কোর্সটা আমি পড়াবো আগস্ট পর্যন্ত। আপাতত দুটো করে ক্লাস নিচ্ছি, পরে যদি দরকার হয় আমি একটা নেবো if required. But the thing is that if I get some time, then I will revise the whole thing, because this topic বলো।
স্যার মানে এই সেমটা অগস্ট অবধি কন্টিনিউ করবে?
ও হ্যাঁ, ক্লাস কন্টিনিউ করবে। কেন বলো তো?
না স্যার, এমনি জিজ্ঞেস করছি না।
কোর্স আগস্ট পর্যন্ত কন্টিনিউ করবে, সেই কারণে আমি ক্লাসটা কমিয়ে দিয়েছি, বুঝলে তো? কারণ অতদিন ধরে তোমরা 4টে করে ক্লাস করতে পারবে না, তাই না, সপ্তাহে। সেই কারণে ক্লাসটাকে আমি কমিয়ে এনেছি, দুটো করে ক্লাস নিচ্ছি। কারণ তবে দুটো করে ক্লাস নিলেও এই টপিকটার মধ্যে তোমরা অ্যানালগ ফিল্টারের ডিজাইন জানো?
না স্যার সেরকম জানি।
হ্যাঁ, তোমরা ওখানে পড়েছিলে না তোমাদের এই অ্যানালগ ফিল্টারে, অ্যানালগ ইলেকট্রনিক্সে পড়েছিলে? হ্যাঁ, হ্যালো, অ্যানালগ ইলেকট্রনিক্স মনে পড়ছে না? বাটারওয়ার্থ ফিল্টার ডিজাইন, সেবিশেভ ফিল্টার ডিজাইন পড়েছিলে? বাটারওয়ার্থ ফিল্টার ডিজাইন পড়ানি, তাই তো? তাহলে তোমাদের ওগুলো তাহলে তোমাদের পড়াতে হবে, তাই তো? তার মানে অ্যানালগ ফিল্টার ডিজাইনটা পড়তে হবে, তাহলে বাইলিনিয়ার ট্রান্সফরমেশনটা এখন পড়তে হবে, অ্যানালগ ফিল্টার ডিজাইনটা পড়তে হবে। এই দুটো হলে তোমাদের যে কোনো ফিল্টার ডিজাইন করতে পারবে। ঠিক আছে, আজকে থাক, পরে আবার কথা হবে। ঠিক আছে, আনটিল দেন। ঠিক আছে, ওকে, থ্যাংক ইউ।
থ্যাংক ইউ স্যার।
Thank you, sir.
Thank you, sir.